Let's talk about AI agents, the next part of our foundations series here on this channel. So far we've learned about what AI is, how it learns, and what's actually happening inside of a large language model when it's responding to you and how it's trained. And the next natural step of that is AI agents. You might have heard about agents, agentic workflow, agent frameworks, words like that going around. And it actually stems from the LLM itself, the large language model, which we spoke about in our last episode. And what we learned there is that the LLM is basically a prediction engine. So you're giving it text or some kind of input, and it's predicting what should come next based on its training one token at a time. That's what we discussed last time. So it's essentially a token predictor. Now, on its own, that can be powerful, but it is pretty limited because it can only generate outputs for you. It can't directly affect the outside world, so to speak. It can't change itself from its core training. So if you ask an LLM to check today's weather, by itself, it actually can't. It has no live connection to anything. It can only generate a plausible sounding answer based on the patterns it learned during training. Those could be wrong, they could be outdated, they could happen to be right, but it's just made up. And so an agent is what you get when you surround that LLM, that prediction engine, with software that lets it plan, use tools, and act on the results that it finds. A good way to think about it is that an agent is basically an LLM, a large language model, wired into a loop. And let's talk about that loop. So the first thing an agent needs to do is look at the situation. The second thing is going to be to reason or decide. Then it's going to take an action. Then it's going to look at the result of its action and then repeat. So of course, in reality, there's a lot of complex things happening code-wise to allow all this to happen. But again, the point of this channel is to explain it in layman terms and practical terms for how you actually use it. And effectively, if you just think of it as this loop happening every time an agent is acting, it makes everything else way easier. Now think about this loop compared to the regular chatbot conversation that you have. You ask something, it gets answered, and that's it. There's one prediction, one output that it's giving you. An agent isn't going to stop there. It can decide that answering isn't enough. It's going to take action to gather more information and make something happen, look at what came back, and then decide again based on that new information what to do next. So it keeps going until the task is finished, not just until it's produced one response for you. Now, an easy misconception to have is that AI agents are basically smarter kinds of AI. And it's actually not. A lot of them are using the exact same large language model that you're using in the chat function of whatever platform you like to use. What makes them feel more capable is the software wrapped around that model. That's what gives it tools and memory and the ability to work through a task over multiple steps. So agents need tools to really be agents. Because remember, that large language model is not actually ever doing anything in the real world. By itself, it can't send an email or browse a website or access your files or a lot of the useful things that you see AI now doing. That's all agentic. That's why early on in ChatGPT or Claude or whatever you like to use, instead of sending an email or searching the internet for something, instead of actually doing it, it would just say to you, I should send an email or I should search the web for this, something like that, because that back then was just the large language model responding to you and predicting the next token. Whereas now with agentic AI, it can do those things by itself. And that's where the tools come in. So tool is basically just a specific function that the agent is allowed to call. Things like searching the internet, reading a file, running a piece of code, or sending a message. These are all various tools that the agent can call upon. So when it decides that it needs to take an action, it doesn't do it directly. It's going to output a structured tool call, sometimes called a function call. And all that does is describe which particular tool should be used and with what inputs. And then a separate piece of software is going to actually carry out that request, and then it's going to hand the result back to the large language model as new information. So again, agents use tools. They use them by structuring a function call to tell the tool which tools need to be used and what they need to do. Software carries out those instructions, and then you have yourself a completed action or answer that the large language model gives you. So remember, that large language model is still just predicting the next token exactly like before. That hasn't changed. The only thing that's changed now is that the prediction includes, because of the agent, when to reach for a tool. The system around that model is built to notice that decision and then act on it. So you can think of it as an intern at work that just has a phone. They don't have a printer, they don't have a car, they don't have a filing cabinet, but when something needs to be printed from a location and then filed in a cabinet, they can call. They know who to call to get that job done. So really the job of the agent is judgment, knowing what needs to happen in what order to complete the task and doing that through the tools available and then turning that judgment into results. So again, the LLM predicting, agent, judgment. Now that we've learned about single tool calls, it's pretty easy to picture that, hey, the agent just asks a certain tool to do something. The hard part is when a particular task is complex and it requires several different steps and they have to happen in the right order, and the agent has to figure out that right order by itself. So if you think about it, if you asked an agent to plan a birthday dinner, it's going to look up restaurants, check which ones have availability, compare prices, and then draft a message to send to your friends. No one handed it that 4-step plan. It has to break down your simple request by itself, decide which order makes sense, and then adjust if something along the way doesn't work, like a restaurant being fully booked, for example. And that's the difficult part with the harder problems when it comes to agents, because the model is basically improvising one step at a time based on predictions rather than following a guaranteed algorithm or verifying each step before moving on. Now, most of the time they work pretty well, but sometimes when the problem is more complex, an agent might loop on the same failed action repeatedly, or it might invent a step that doesn't actually make sense, or it might confidently declare that it's finished a task even though it hasn't. And that's not an issue with it being unintelligent the way we understand that word. It's just a result of how it works. It's predicting the next plausible step. It's not verifying a correct one. Another key thing to keep in mind is memory, because that can be another limitation of agents. So during a task, an agent's going to keep track of what it's done by storing information in the context of the conversation or other temporary working memory that it's using to complete that task. Now, once that task ends or once that context window has filled up, and we've talked about that in a previous episode, that information is essentially going to disappear unless the surrounding system running the agent or running the task saves it somewhere permanent and then provides it again later. So remember last time we spoke about context windows? That's the amount of information a model can actually see, quote unquote, all at once. It's the agent's memory of what it's done, what tools it's called, what it's learned along the way. All of that lives in the same context window. And those context windows are getting bigger and bigger as these frontier models release newer and newer models, but the tasks are also getting more and more complex. So once a task ends or that window is full, older information might get pushed out, and that memory is gone unless something outside the model was built to save it. That's why some agents feel like they remember your preferences from like a week ago, and then other agents, if you open up a new chat, it's like you've never chatted with it before. The difference isn't the underlying large language model. It's just whether or not the surrounding system was built to write information down somewhere and hand it back to the model later. These are obviously very simplified terms, but just keep in mind that context window and memory capabilities matter a lot when it comes to agentic AI. And that's why you see this huge boom in memory company stocks, everyone going crazy about chips and all that stuff. It's because of reasons like this. So really the effectiveness of that AI agent is really going to depend on how big that context window is and how much working memory it's operating on. Now, the reason AI agents matter is because it's the direction the entire industry is moving towards, because an LLM that can only talk to you is kind of cool at the beginning, but what's way more useful is one that can talk, check things, act, and just operate on its own. So think about all the use cases like customer support systems that can actually resolve issues and solve tickets instead of just answering questions based on a database. Research tools that could search, cross-reference, compile all the findings instead of just summarizing what you're pasting in. Coding agents that can run your code, see the error, fix it, and not just suggest a fix. Just keep in mind, though, the same limitations we talked about with large language models also apply to agents. However, because that agent is actually acting on information rather than just giving it to you, when those limitations apply, the stakes can be higher. So when an AI agent hallucinates, it's not just giving you a wrong sentence, it can take the wrong action. And that's why a lot of these frontier models, they put a lot of systems around the agents, like guardrails, to limit what tools these agents can actually access. A lot of them will confirm with you before making any changes or taking certain actions, and just build these checkpoints along the way before letting the agent just run wild. So remember, agents are not smarter AI. They're built around that same large language model, just with access to tools and the ability to use those tools through a plan that it comes up with and reassessing the result it spits out and adjusting along the way. But the core idea is the same. It's just a prediction engine. It's making one decision at a time inside of a loop, and it makes sense when you look at it that way. It's not magic. It's not truly autonomous thinking in the way that, the layman person might think of that term. It's the same core mechanism. It's just predicting the next token, but now you can think of the agent as that large language model being given hands, eyes, and memory to work with rather than just the basic model. So that's pretty much it for AI agents. We hope that was helpful. Check out the newsletter and resources in the description. We're working on a lot of cool stuff there. And let us know what else you want to hear about. We'll see you next time.